Lesson 4.7 is inverse trigonometric functions. Now, I will mention, did you notice we skipped a few lessons? We kind of jumped from 4.3 to 4.7. 4.4, 4.5, and 4.6 are all three about graphs, if I recall. And so I can go back and do those later, because we're going to look at what does the graph of sine look like, the graph of cosine. We'll do secant, cosecant, we'll do tangent and cotangent. And so that is something to come up, but what I tend to do is I'll do 4.7, we'll go ahead and do 4.8, and then after that I do like a test over the bulk of chapter 4. And then after that test, I usually go back and teach the graphing sections. So that's kind of where we'll be headed if you're keeping track. So inverse trig functions. You remember when we were trying to do reciprocal functions and I said do not use the second sine, second cosine, and second tangent buttons? This is what they are. Okay? They are the inverse functions, which is different from a reciprocal. Reciprocal is just taking a fraction and flipping it upside down. Inverse functions, and what do you guys remember from Algebra 2? I just taught it actually in this year's Algebra 2, but what do you remember about finding an inverse? Remember how to find an inverse function?
You have to switch the x and y.
You're switching the x and y, right? Okay, so when we think about switching an x and a y, we generally think of x as the input, y as the output. When we switch x and y, we're switching the input and the output. So top of this page, we're going to talk about inverse sine. Bottom on, we're going to talk about inverse cosine and tangent. Now, there are some times that, well, I'll ask you to use a calculator. There are times we need to be able to do this without a calculator, though. And so understanding what it means there. Now, inverse sine function, you notice y equals sine negative 1x. You will also see, I think this book uses it as well. Another notation they will sometimes use is arc sine x. Okay, I know my calc book uses that a lot. Pre-calc book, you'll see it a little bit of both in homework. Where sometimes they'll say sine at negative 1, sometimes they will say arc sine. Those are the same. Okay, so just be aware. Same thing will be true of cosine and tangent. They say arc cosine or arc tangent. It's the same thing as saying sine inverse. Okay, so let's talk about domain and range. Domain is we always think x values, right? Or domain is our input. What are we putting into the function? Range being our output, what are we getting out of the function? And so, as we talk about domain here, the domain of the inverse sine function is negative 1 to positive 1. So, when we talk specifically about the domain, so your input values have to be between negative 1 to positive 1. Period, end of statement. If you have a value outside of that domain, from negative 1 to 1, you can't do the inverse sine of it. If you try and type it on your calculator, you'll get an error. Now, so we've got negative 1 to 1 for our domain. Range. So this is going to be our output. The range of the inverse sine function is negative pi over 2 to positive pi over 2. So now when we talk about inverse sine, all of our answers, so all of what comes out of this function, will be somewhere between negative pi over 2 to positive pi over 2. Now, as we've been working with sine lately, do you understand how this is flipped? Usually, what are we putting into sine? We're usually trying to take the sine of 30 degrees, or pi over 4, or 60 degrees. Or, we're usually trying to take the sine of some angle. And if you look on the chart, we're getting numbers out, right? We're getting 1/2 out. We're getting 2 out. We're getting square root of 2 over 2. We're getting those numerical values out. Sine inverse flips it. We're putting those numbers in, and we're getting out the angles. So notice what it says right here in the next part. The answer to the inverse sine function is an angle. So regular sine, we put in the angles. Sine inverse, we are getting angles out. Okay, thus inverse. X and Y are flip-flopped. Okay, let's look at example 1. Notice the directions. Find the exact value of each of the following without a calculator. First of all, when they find exact, we never want a decimal answer there. Okay? I mean, I get it. You get 0.5, you know that's 1/2. But square root of 3 over 2. The exact answer is square root of 3 over 2. Whatever that is a decimal that your calculator would give you, that's not what we want. So right here, again, we're practicing without the calculator. So, now, before I forget, on the back of your page, on the back of your notes, you have a page that looks like this, yes? Okay, I was able to figure out how to rotate this morning. But let me kind of point out, and we're just talking about sine here, right? So right here is sine inverse. This graphic here represents our range values. These are the possible range values for sine inverse. So these are my possible answers. Anytime I do a sine inverse, my answer has to fall over here. If I get an answer in either of these left two quadrants, it doesn't work. And I'll kind of explain more about that as we go. But notice the top number is pi over 2, which, for those of you that still like to reference degrees, which is all of us in my opinion, pi over 2 is the same as 90 degrees, right? Now, down here, they have pi over 2 all the way down to negative pi over 2. What is negative pi over 2 equivalent to?
Negative.
Okay. Officially, the exact calculation is negative 90 degrees. Now, what you need to notice is when we give our answers, the top quadrant 1 is what you're used to getting. Quadrant 4, notice, is this labeled as 3 pi over 2? It's not, is it? Okay, it's not labeled as, what, 5 pi over 3, I'm trying to think what they are, 7 pi over 4, or 11 pi over 6. So you're not going to give me an answer like we typically see on our unit circle of, in quadrant 4, 5 pi over 3, 7 pi over 4, 11 pi over 6. We actually are required to give the negative equivalency here. Okay, and we'll work on that. It'll make more sense as we go through the examples, but I wanted to realize, okay, sine inverse. Your answers have to be in quadrant 1 or quadrant 4. Got it? Okay, going back here. Let's try example A. Find the exact value of sine inverse of 1/2. So as I talk about sine inverse of 1/2, 1/2 is my domain value. Does that work? Is that an acceptable value in my domain? My domain is negative 1 to 1, so 1/2 is possible, isn't it? Okay, well, equals, we need a range value now. So normally, we say the sine of some angle equals some value. Now I'm flipping it. Sine inverse says the sine of what angle equals 1/2. The sine of what angle equals 1/2. Thoughts?
30 degrees.
Okay, give it to me in radians though.
Pi over 6.
Pi over 6. The sine of pi over 6 is equal to 1/2. Where did he get that value from? That came from the chart, yes? I said it was going to be helpful to have the chart filled in today over there so I can just point at it. But you're looking for, okay, I see sine. Sine of what angle equals 1/2? Well, I see sine of 1/2, that is 30 degrees or pi over 6. Traditionally, you give your answer in radians, so. Okay. Does pi over 6 fit in my given range? And yeah, pi over 6 is a first quadrant angle, so yes, it fits. Questions on that one? I'm going to say stop me as you have a question, right? Okay, let's try B. Sine inverse of negative square root of 3 over 2. First of all, is my domain acceptable? Is that value between -1 and +1? And here's what my brain says. I know square root of 3 is like 1.7. When I take 1.7 and divide by 2, am I going to be under 1? And I am going to be, right? 1.7 divided by 2, 0.8 something probably. So I can kind of, judge that, okay, yes, this is possible. And, square root of 3 over 2 should be a familiar value to you right now, shouldn't it? That's one that you know, oh, yeah, I'm going to have to use that on my quiz tomorrow. So that's familiar. Okay. My recommendation here would be forget the negative for a moment. Okay. At what angle does sine equal square root of 3 over 2? Okay, according to our chart, pi over 3, yes? Sine, square root of 3 over 2 is in the pi over 3. Now, I'm going to write that down for a moment. If this just said, at what angle, and actually I probably shouldn't have written it down yet, now that I think about it, but if this said, at what angle does sine equal square root of 3 over 2, it would just be positive pi over 3, yes? Here's the deal. Okay, guys. I'm going to just put in a very small little picture. First of all, where are my answers allowed to be? My answers are only allowed to be in quadrants 1 and 4, correct? I'm not allowed to, based on what's on the back of your paper, right? I'm only allowed to have answers in quadrant 1 and quadrant 4. Now, the angle we're talking about is pi over 3. But quadrant 1 is our positive sine angle, isn't it? Remember that all students take calculus? That still applies. Quadrant 1 is a positive sine quadrant. What do we know about quadrant 4? It's positive for cosine, it's negative for sine, isn't it? So here's my question to you. What is the equivalent angle down in quadrant 4? So pi over 3 up, what is the equivalent angle down in quadrant 4? If we look at the regular unit circle, what are you guys tempted to tell me? The equivalence of going pi over up is the equivalence of going down to 5 pi over 3? That's what you want to tell me, isn't it? Now, notice how I'm saying that. That's not what I need you to tell me, though. Because if I go back to this page, is 5 pi over 3 listed down here? Do I get to use 5 pi over 3? No. I have to use an equivalence from negative pi over 2 to positive pi over 2. So pi over 3 up is equivalent to what down below? It's easy. Pi over 3 down. So in this one, in sine, if you have to go down to the negative quadrant, you really can just put a negative in front of the angle. It works for sine. It won't always work, though. We'll talk cosine here in a little bit. So I am looking for a negative pi over 3 there. And that's because that's the equivalent angle down in quadrant 4. You tell me 5 pi over 3, it is the correct location, but I have to be specific about the name because we're working with inverse sine. Questions I can answer on that one? I didn't write it here, but this is our range, and that's acceptable range value, right? Okay, C. Sine inverse of pi over 2. So remember how I ask these inverse questions. At what angle does sine equal pi over 2? At what angle does sine equal pi over 2? First of all, did you check your domain? What do our domain values look like? Domain values are numbers between what? -1 to +1. Is pi over 2 actually an angle here? Is our domain angles? No, our domain is not angles. Our domain are just numbers. So pi over 2 here, it's a number. It's not pi over 2, 90 degrees, the angle. It's a number value. So what is pi over 2 as a number? It's not 1. What is pi over 2 as a number? In other words, what are we trying to find sine inverse of? Pi is approximately what? 3.14. You take 3.14 and you divide by 2. What's 3.14 divided by 2? I know it is 1.57 something. Could you at least say it's around 1.5? Because you know half of 3 is 1.5. What do we know about 1.5 or 1.57? What? It's above 1. Is that a problem? That's a problem, isn't it? Okay. My domain, in order to do a sine inverse, my input has to be between -1 and +1. They're trying to trick you here, right? Because they're trying to get you to think, oh, pi over 2, I just need to find the sine of pi over 2. But no. Sine inverse, this input is a number. Notice. Well, I guess the rest we're going to change kind of up what we're doing, but this is a number. This is not an angle. So, with that in mind, you're trying to do sine inverse of 1.57. 1.57 is not in the domain. So, what are we going to say about this one? It does not exist. And I know we haven't started using the calculators on this, but you would get an error if you put this into your calculator. Your calculator's not going to do it for you. It's going to say an error. It's probably going to say a domain error or something like that, because we can't do it. So this is a domain error, and I'm going to say because pi over 2 is outside of domain. So if you're looking back at this later and trying to figure out why does it not exist? Because that pi over 2 is bigger than 1. Questions on that? Okay. Ask questions as you get them. Are we ready for D? Okay. D, we're going to add a step in here, aren't we? We're doing the sine inverse of sine of pi over 3. Well, what do your math brains tell you about lots of parentheses? Or when there are parentheses? We start where? We're going to start on the inside. So start there on the inside, meaning forget sine inverse for a moment. I don't care about that. Start with what is sine of pi over 3. I'm not asking sine inverse. I'm saying sine. So what is the sine of pi over 3?
Square root of 3 over 2.
No tricks, right? Sine of pi over 3 is square root of 3 over 2, straight off the chart. So that sine of pi over 3, I can replace with square root of 3 over 2. I'm not done, though, because out front we had a sine inverse. So now we're doing sine inverse. And now I'm going to ask you, remember how I asked sine inverse, at what angle does sine equal square root of 3 over 2? At what angle does sine equal square root of 3 over 2?
Pi over 3.
Pi over 3? And since that's a positive square root of 3 over 2, we're going to stay in quadrant 1, which is just pi over 3. And I guess now that I think about it, I kind of skipped the domain question. Are we in the domain? But then again, didn't we already do sine inverse of square root of 3 over 2 earlier, just the negative version? So that tells me we're okay. But did you notice what happened here? What did sine inverse and sine do to each other? They undid each other, didn't they? Or if you think about it, sine and sine inverse, when they're switching each other, they just end up switching right back then. Now, I'm going to give you the warning now. Don't always assume that, oh, if it says sine inverse of sine, my answer is just going to be pi over 3. That works because pi over 3 is part of my range. It's a little different if my angle was not part of my original range here, the inverse range. In this case, though, it worked. I always encourage you to work your way through it, which I'll demonstrate on E, so you can watch out for the catches. Are we okay with D? Okay, let's try E then. Sine inverse of sine of 5 pi over 6. So we're going to start with the inside. I don't have to worry about domain and range right now. I just have to find the sine of 5 pi over 6, which is what we've been doing the last several days, week, whatever, right? Now, thoughts on sine of 5 pi over 6? Do we know how to find it? What quadrant is 5 pi over 6 in? Five pi over 6 is in quadrant 2. And I know that because it is right before pi. 1 pi is the same as 6 pi over 6. I also know that because I can look straight at the unit circle over on the wall there, but I never want you relying on just looking at a unit circle, because as you go through math, you won't always be allowed to have that unit circle in front of you. Pre-cal, I'll be honest, I allow you to have it in front of you. Calculus, I don't, because AP test doesn't allow you to have it in front. So AP, you have to be able to know more about it. Pre-cal, I kind of baby you guys about it. I let you have it in front of you. But don't rely on it is what I'm always going to say. Okay, so what are we asking ourselves? How far is 5 pi over 6 to 6 pi over 6? It's pi over 6, right? So what is the sine of pi over 6 in quadrant 2? Well, sine of pi over 6 is 1/2. What do we know about sine in quadrant 2?
Positive.
It's positive. So sine of 5 pi over 6 is positive 1/2. We okay with that part? Now, I'm doing my sine inverse of 1/2. First of all, now that I'm doing sine inverse, is 1/2 an acceptable domain value? Is that an acceptable input? Yeah, because it's between -1 and 1. So, at what angle does sine equal 1/2? And that is?
Pi over 6.
Thank you very much, David. Pi over 6. Because it was a positive 1/2, we use the quadrant 1 angle of pi over 6. Now, it was different this time, wasn't it? It didn't just say sine inverse and sine didn't just undo each other and give us 5 pi over 6. Why did we not get 5 pi over 6 this time? Is 5 pi over 6 in my acceptable range? No. 5 pi over 6 is over here in quadrant 2, but we're not talking quadrant 2. We need quadrant 1 and 4. So 5 pi over 6 over here in quadrant 2 is equivalent to pi over 6 in quadrant 1. That's based on distance from the x-axis. Okay, so I wanted you to see the difference between the two here. Here they undo each other. It was already in quadrant 1, so we're good. Here, this wasn't in our range, so that's why it ended up changing. Okay, there's one more squeezed in there. Did you see it? F. Sine inverse of -1. So first of all, is that an acceptable domain value? Yeah, because my domain is -1 to 1. -1 and 1 are included. So yes, we're good on the domain. At what angle does sine equal -1? Is 1 over there on my chart for sine? It's not, is it? And we're talking sine, aren't we? Okay, you've done this though. I'm holding up a unit circle. When does sine equal -1? What'd you say?
90.
Not 90.
Negative.
Okay, so up at positive 90, sine is 1, right? Remember our ordered pairs? Cosine, sine. So at positive 90, sine is positive 1. Down here at 270, if you will, sine is -1. Now, you guys went straight to -90 for me, though. Can I say 270 is my answer? Actually, we're not even going to say 90 is our answer either. We're going to use our pi's, but I'll talk degrees with you, I know. So here's the idea. Sine equals -1 down here at, how about if I say 3 pi over 2? Okay. And I'm willing to talk 3 pi over 2 with you. However, you can't leave 3 pi over 2 as your final answer because that's not in our range. What is another name for 3 pi over 2? And if you flip on the back of the page, it is negative pi over 2, right? If you look on the back of your notes. So we need to give the answer of negative pi over 2. And I'm giving that because this whole 3 pi over 2 thing is not in the range. Sine inverse starting to make some sense? Not saying it's the easiest, but it's a necessity. Or maybe it's a piece of cake for you guys. I don't know. Ready to try example 2? The part you've all been waiting for. Use a calculator. So grab the calculators out so you make sure you know to hit the right buttons. They're being nice, and they're saying use a calculator where? In radian mode. Unless you are specifically entering degrees, you want to use radian mode. Okay, anytime I have a trig function, you want to talk radian. So, use a calculator in radian mode to evaluate these inverse sine values. It is easy, guys. How do I do sine inverse? This time I'm not doing a reciprocal. I am doing sine inverse, so you're going to use the second sine button on your calculator, right? So type in second sine, negative 0.81. Who's going to be brave and tell me what they got? I have 3 decimal places written down, but yes. I have negative 0.944 written down in my notes. Obviously, I know it's a big, long calculator thing, so do you put that up on the screen, or are we all getting our calculators to cooperate? Make sure you're in radian mode, and make sure you use the second sine button. This is the time you get to use it because it's an inverse function. And you're typing in because you're already doing part B, yes? Type in what you see on B. So start with sine inverse, which is your second sine, and then actually type regular sine, and then 3.49, and then use the pi symbol, please. Okay? Officially, if you don't put those parentheses at the end, I don't think it'll affect your answer. It usually doesn't. What'd you guys get?
Negative 1.53.
I have negative 1.539 with my 3 decimal places, but yes. Oh, did you say the 9 on the end?
Yeah,
I missed the 9 on the end. I heard the negative 1.53 and then you're kind of hesitating and I just missed it, so. Okay. Calculators cooperated with you then? Okay, the bottom half of the notes are inverse cosine and tangent functions. Okay, so cosine inverse x, tangent inverse x. Just like sine, you can use when you're doing a calculator type problem, you can use the second and the cosine or the tangent button. You will also sometimes see them written as arc cosine and arc tangent. And as I said, if I recall correctly, the book mixes them up, so they use a little bit of both notations. What you will notice is that inverse cosine has a huge, the domain and range are, has different information, doesn't it? I guess half of it's the same. And so with cosine, you've got that domain of negative 1, 1, which is just like sine, but you have a range of 0 to pi. So if I look at the back of your notes, when I talked earlier that, okay, sine inverse, you get quadrants 1 and 4. Cosine inverse, you get quadrants 1 and 2. You can't come up with anything down in quadrants 3 and 4. While I'm here, tangent inverse, it looks a lot like sine, doesn't it? Except notice what's at negative pi over 2 and positive pi over 2? There's x's there. And so if you're looking at your notes, it's negative pi over 2 to positive pi over 2, but the endpoints are not included. So that's the big difference. So sine inverse, tangent inverse, it's the right half. Cosine inverse, it's the top half. And I went the wrong way. So that's probably where we'll spend our time talking tomorrow. We'll practice some of these. They are going to be, for the most part, pretty similar to what you saw in the top half. So we'll do that after the quiz tomorrow. Okay?
Homework due Thursday?
Correct.